Section 8.7 Improper integrals, which are integrals that involve infinity. There are two types of improper integrals. The first type with infinity as upper limit, lower limit, upper and lower. Now, before we start to see how do we evaluate these integrals, we must say now, if the answer of this integral is equal to a number, then we say the integral converge. But if the answer is plus or minus infinity, then we say it is diverge. Now, how do we evaluate these integrals? To evaluate a to infinity, we have to replace r infinity by r and say limit of r goes to infinity. We must calculate the integral first, replace a and r, upper and lower limit, and then calculate the limit when r is infinity. So put r equal to infinity, which means we are actually saving the infinity using r until the end of the answer. As simple as that. If we have to calculate or evaluate minus infinity to a, then we have to replace minus infinity by r and say r goes to minus infinity. Calculate this first and then calculate the limit. If we have minus infinity to infinity, we cannot start replacing r as upper and lower. We have to separate the integration into two integration using any number in the middle. Usually we use 0. Then we have to calculate the first one separately and the second one. If we calculate the first one and the answer was infinity, which means it is divergent, then we have to stop and say this integral is divergent. Otherwise, if the answer for the first one is a number, so it is converged, we have to continue and calculate the second one. So here note, if either of the integrals diverge, then the original one diverged. So let us see now some examples on the first type of improper integrals. Now before we start solving the example, let us have a look at the graph of this area to see the meaning of improper integration. You see the graph of 1 divided x squared from 1 to infinity, it looks like something like this. We have to calculate the integration from 1 to infinity. Now this is open area, it's unbounded area, which we are not used to. You see the answer of this integration, it depends really on how the curve behaves at x equal to infinity. If it goes very near to the axis, then we are going to get an answer which is not infinity. But it does not go very close near the axis, the answer will be infinity. So it's improper integration because it is not bounded area. Anyway, let us see how to calculate this. We are going to take the limit as r goes to infinity and put r here. And then we are going to see what is integration and do the infinity at the end. The integration is minus 1 divided x from 1 to r, which is equal to r goes to infinity. This is minus 1 divided r plus 1 divided 1. If you put r equal to infinity, it will be equal to 1 divided infinity to 0. So it is a convergent answer, which means this area is equal to this area is equal to 1, which means that the curve goes very close to the x-axis, so it is like a closed area. The second example, this is 1 divided x, which looks like something like this from 1 to infinity. It almost looks like 1 over x squared. But how close it goes to the axis, let us see. We have to calculate the same area, almost, but the answer will be totally different. If we take limit, r goes to infinity, 1 to r, 1 divided x dx, that will be equal to the limit r goes to infinity, ln x is positive, so we can leave it with that absolute value, 1 to r, which is equal to the limit r goes to infinity, ln r minus ln 1. Now, if we do the limit using substitution, it will be ln infinity minus ln 1, which is equal to infinity minus 0. This is infinity, so it is a divergent answer, which means that this area is equal to infinity, because the 1 over divide x is not like the 1 divide x squared. It does not go very close to the x-axis when x goes to infinity, so this is an open, it's open area, and it does not go very close to the axis, so the answer was infinity. Now one more example for the first type of improper integration, which is integration from minus infinity to infinity. Now since we have two infinities, we have to break this into two integration using any number in the middle. We can use a 0, for example, or a 1. So minus infinity to 0, 0 to infinity, 1 divide 1 plus x squared dx. Now we have to calculate this and this separately. If the first one diverges, then we stop and we say the integration, which is this one, is divergent. Now let us see the first one. So for first one, we're going to say the limit when r goes to minus infinity, integration for r to 0, 1 divide 1 plus x squared dx, which is equal to the limit r goes to minus infinity, integration of 1 divide 1 plus x squared is tan inverse x from r to 0, which is equal to the limit r goes to minus infinity. You replace now 0 and you replace r, which is equal, now you put the infinity, you have tan inverse 0, which is 0, minus tan inverse minus infinity, which is minus pi over 2, so this is minus pi over 2, which is equal to pi divided 2. So that's the first one, which is convergent. So we must continue and see the second one. Second one, in a similar way, r goes to infinity, 0 to r, 1 plus x squared dx. This is equal to limit r goes to infinity, tan inverse x from 0 to r, which is equal to the limit r goes to infinity, tan inverse r minus tan inverse 0, which is equal to tan inverse infinity minus tan inverse 0, which is 0. Tan inverse infinity is pi divided 2. So final answer, integration from minus infinity to infinity for 1 divide 1 plus x squared dx is equal to this plus this, which is the first part plus second part. So it's equal to pi divided 2 plus pi divided 2, which is equal to pi. The second type of improper integral is when the function of x is infinity. When the function is infinity, not a and b. Now, what is the meaning of this? Consider this example, which is 0 to 1, so the limits are not infinity. The limits are not infinity or minus infinity, but we have 1 divide x, which is infinity when x equal to 0. So the infinity is because of f of x. If you look at the graph of this area, actually this is 1 divide x, and we have to calculate the area from 0 to 1. So the area is open here because of y. So number 1, we have if we said here, if we have discontinuity, if f of x is discontinuous at x equal a, then we have to replace a by r, and we say r goes to a from the positive side. Positive side because we have a closed interval here, a to b, the integration from a to b. So if we approach a, it has to be from the right, and if we approach b, it has to be from the left. This is a number 2. if f of x is discontinuous at b, so if the function is infinity here, then we have to replace b by r and say r goes to b from the left. And if the function is discontinuous not at a or b, at a number between a and b, so in order to replace this number by r, we have to break the integration at the number which is c, where we have discontinuity. Then we have to do two integrations. Replace c by r in every case. And like we said before, if the first one is divergent, then we stop and we say this is divergent. Number 4, if we have discontinuities at a and b, in this case also we have to break the integration using any number in the middle, and then we have to replace a by r and b by r, both discontinuities, and do also two integrations, and if one of them is divergent, we stop and say this is divergent. The best thing to see actually this second type is when we look at the examples, and this is what we are going to do next. Now, let us start some examples on the second type of improper integration. The first one, we have integration from 0 to 5, so we don't have infinity here, but 1 divided x squared is infinity if denominator is equal to 0. Denominator will be equal to 0 because we are going to have 1 divided 0 when x is equal to 0. So let us see how to do this integration. So we have here at x equal to 0, we have discontinuity. So we have to say the limit r goes to 0 from the right, from r to 5, 1 divided x squared dx. Then we have to integrate and then replace r equal to 0 at the end. Integration of this is minus 1 divided x, r to 5, replace, this is r, replace x by 5, then by r. Now put r equal to 0, so it's going to be minus 1 divided 5 plus 1 divided 0, which is equal to infinity. So this integration is divergent. Now this is another example for the second type of improper integration. Now we don't have infinity here, but the function, this function is infinity when denominator is equal to 0, denominator is equal to 0 when x equal to 5. Now, so we are going to say this is limit r goes to 5, because we have infinity here, goes to 5 from the left. So we are going to replace 5 by r. Now we are going to integrate. This is r minus 5. Let's write this as 2 5 minus x to the power minus half dx, which can be integrated as 2 5 minus x to the power minus half plus 1, which is half, divide by half, but we need a minus because derivative of minus x is minus 1, from 1 to r. This is equal, r goes to 5 from the left. Now we are going to replace r and then 1. If we take this up, this will be minus 4 square root of 5 minus r minus, this is minus 4 square root of 5 minus 1, which is equal to, now we are going to put r equal to 5 to calculate the limit, so it will be minus 4, 5 minus 5, which is 0. This is a plus 4 root of 4. This is equal to 0, so it will be 4 root of 4, which is equal to 8. So this is a convergent integral. Now this is another example for the second type of improper integration. You see here, we don't have infinity at the values of x. Okay, tan x is defined at x equals 0 and x equal to pi, but tan x is equal to infinity when x is equal to pi divided 2. Pi divided 2 is inside the interval 0 and pi. So we have to break this integration to two integration and replace the discontinuity, which is pi over 2, at the limits of the integration. So we have pi divided, so we have to break it using the discontinuity. We have to break it at pi divided 2. Now we have two integrations which we have to calculate. If the first one is divergent, then we stop and say the integration is divergence. Now the first one, this is limit when r goes to pi divided 2. You see, that's the reason we put pi divided 2 as upper and lower limit, because we have discontinuity, so we can replace it by r now, 0 to r. When it's in the middle, we cannot replace it by r. Tan x dx. This is equal to the limit r goes to pi divided 2. Integration of tan x is len secant or minus len cosine. Same thing, 0 to r. Now, this is equal, if you replace r, it will be cosine r plus ln cosine 0. Now we do the limit, put r equal to pi divided 2, so we are going to have len cosine pi divided 2, and ln cosine 0 is 1, so this is len 1. Cosine pi divided 2 is 0, so this is len 0 and len 1. Len 0 is equal to minus infinity, so this is plus infinity or plus infinity. Len 1 is 0, so this is infinity, which means that the first integration, which is this, is divergence. So we don't have to calculate the second one. We just have to say that the integration from 0 to pi for tan x dx is divergent. Now this is another example for the improper integration. We have integration 0 to infinity for 1 divided x dx. Now, having an infinity here, it is a very clear improper integration, but this should not make us jump to the conclusion that we are going to replace this infinity by r and that's it. Having finished the two types of improper integration, we must always check the discontinuities of this function. For example, 1 divided x is discontinuous when x is equal to 0, which is this, which means we have here improper integration at a and at b. So we have to break this integration and keep only one improper each time. We can choose 1, for example, so from 0 to 1, 1 to infinity. So we have to break it because you cannot have 2 at one integration, because we are going to replace it by r. Now we have to calculate them separately, and if the first one is divergence, we are going to stop 0 to 1. So the first one will be calculated like this. It will be limit r goes to 0 from the right, because we have 0, which is improper integration, for integration r to 1 divided x dx, which is equal to the limit r goes to 0 from the right, 1 divided x as len x. Here it is 0 to infinity, so we don't need absolute value, from r to 1, which is equal to the limit r goes to 0 from the right, ln 1 minus ln r. Now we replace r by 0. ln 1 is equal to 0 minus ln 0, which is equal to 0 minus ln 0 is minus infinity, so the answer is infinity. So the first integration is infinity, which is divergent, so we don't need to calculate the second one. We can just say that 0 to infinity 1 divided x is divergent. because that was the first one was divergent. Before leaving this section, we're going to see one more example for the mixed types of improper integration. We have infinity, we have minus infinity, this is dx, should be dx, and also this is infinity when x equal to 0 and 0 is inside this integration. So we have 3 improper integrations. So we have to break this integration in the following way. We have to say minus infinity to minus 1. We cannot jump the 0 because the 0 is improper, so we cannot have 2 here, improper integration. We have to do until and minus 1. Then minus 1 to 0, which is improper now, 0. So we have only one improper integration here. And from 0 to 1, 0 is again improper. And 1 to infinity, infinity now is improper. That's the only improper integration here. So we'll have to do 4 integrations. If any one of them is divergent, so we are going to stop and say this is divergence. If the first one is divergent, it will be good news to us because we will have to stop and we will not have to calculate all of this. Anyway, let us see. To calculate the first one, we have to say the limit r goes to minus infinity r to minus 1 for x to the power minus third dx. This is equal integration of x to the power minus third is x to the power 2/3 divided by 2/3, so multiply by 3 over 2 r2 minus 1. Now, if we replace 1 and r, we are going to have 3 by 2 cube root of minus 1 square and 3 by 2 the cube root of r square, which is equal to, let's fix this first, this is the cube root of r square, which is equal to, if you put minus infinity for r now, this is going to be 3 by 2 because the cube root of minus 1 is minus 1 square is 1. Then minus 3 by 2, you have a cube root of minus infinity square. Cube root of minus infinity is minus infinity, square is infinity, so this is equal to minus infinity because of this minus. So the first one is divergent, which is a very good news to us because we don't have to calculate the rest. We can just say the integration for 1 divide cube root of x dx is divergent.